discussion of this particular definition of the device called as finite automata. I told you why this device we refer to it as a finite device, because the number of states in this device are finite. Okay, that's why we call this device as finite device. The definition of finite automata is like this. It's a 5-tuple representation or 5-tuple data structure which has q, sigma, delta, q0 and f, where each one of them are defined as q is finite set of states, sigma is an input alphabet, delta is a mapping between current state, current input to next state, and in mathematical terms delta is q cross sigma mapped to q. This is referred to as transition function. There is a particular state q0 in input state set is referred to as initial state. So this is the state in which the device lies when the simulation or the working of the device starts. Finally, in this particular 5-tuple definition, we have f, which is a subset of q. Itself it is a set and it's a subset of q, referred to as accepting state. So it is collection of all the states in the given automata that are part of or composed of acceptable inputs. Okay, जो भी acceptable inputs है वो inputs लेके डिवाइस जिन जिन स्टेट में पहुंच सकता है, those states are referred to as final states. The example automata that we looked at of flipping the switch, and there are uh, two states. Okay, one of the state was mentioned as final, double circled one, और जो single circle state था वो non final था. Okay, and we actually distributed or divided or partitioned all the inputs that can be received by our device into two partitions there. One partition was a valid string partition. These were the string using which my device was always going to go into a final state, whereas all the other strings were the strings, if I give those strings as input, my device was always going to be end up into a non-final state. Now whatever I'm speaking, it will make more sense if we actually looked at some other device with some other configuration. So bear with me for my drawing skills for a few more uh, minutes. So I'm going to draw a transition model for another automata. Okay, this time this automata will have more than one state, or more than rather two states. So the first example of our automata had only how many states? Two states. Now this automata is going to have more than one state. Okay, so this particular automata, let me first draw it. Okay, I'll be marking the name of the states. Generally, when we name the state of the automata in this particular subject, we mention them like the initial state is mentioned as q0, and the rest of the states we also mention them like q1, okay, and q2. So these are the three names that I'm giving to the states. I may give any names to the state. That doesn't matter, right? It's a choice of designer who gives the name to the state. So this is some computation, okay, which is having one final state and two non-final state. So whatever inputs which are now be given to this device, they can either take you to state Q0, Q1 or Q2. For example, we will try to give different inputs and verify which state we reach with that particular input. Say this is the first input, this is the second input, and this is the third input. So these are the three inputs which I am going to give to this particular device. As such, with the definition that we know of finite automata, we'll first check whether this particular device is a finite automata or not. तो कैसे चेक करना कोई गिवन मॉडल जो है डिवाइस का वो फाइनाइट ऑटोमेटा को रिप्रेजेंट करता है या नहीं करता है. ए, it should have all those 5 components. Which components we were talking about? We were talking about having Q set, having sigma set, okay, having some transition model. Okay, that should be a function between current state, current input to next state. Okay, then we need to have a particular state in Q referred to as initial state. It should have an initial state. So device must be in this state when the working of the device starts. Every time I give an input first time, it should be in this particular state. The next thing that the device should have is set of final states. Now we'll try to fill up all this information in order to understand whether we have this particular device as a finite automata or not. Now the restriction on Q is that Q must be finite. So Q must be a set and a finite set. Two properties should be there. Yes, so Q is a definitely set because we have Q0, Q1, Q2, three states represented by three nodes in the transition graph. So this is transition graph. I have three states Q0, Q1, Q2 in the transition graph. Next thing that I have is if I see or observe all the labels, labels are generally the inputs from the alphabet set. So there are two labels that I can see which are distinct, 0 and 1. So with this, I can conclude that my alphabet set is 0 and 1. So that means my input is to be composed of 0 and 1. I have an initial state called as Q0. Okay, so I'm naming it Q0. So convention wise, it's the initial state. Okay, and how did I identify that Q0 was initial state? Because of this leading arrow. ये वाला जो leading arrow है ये indicate करता है कि node Q0 represents initial state because this arrow is not having any label and it is not starting at any state. It is an arrow which is a dangling arrow, right? ये dangling arrow जो दिख रहा है that is referred to as the arrow indication for initial state in transition graph. Okay, fine. How do I identify which is the final state? This final state will be a node that has double circled. Okay, it will be a double circled node. Okay, इतना फैट नहीं होगा, थिक नहीं होगा, लेकिन डबल सर्कल नोड होगा तो वो नोड रहता है आपका final state ka. So how many final states are there? Only one state is there in the set of final states. So since I'm saying that it is a final state set, it may contain multiple final states as well. Okay, but this time around for this example computation, we have Q2 set. Now, what is this model? So this is called as the transition model, and the transition model is determined using this transition diagram. So there is this particular kind of transition model available. So I have how many states? Three states, Q0, Q1, and Q2. Okay. Out of these three states, Q0 is my initial state. This again arrow is indicating same. Q2 is final state. In the transition table, when I draw it, I mark a star before Q2 to indicate that it is a final state. Okay, so it's a star for Q2, not for Q1. Please understand that. Our row here. Okay, now there are two choices of input that I have. One choice of input is 0. Last example, we only had one input, so one column was there, and there were two rows. Now there are three states, so there are three rows, and two alphabets, so there are two columns. This is how you write this particular table. This is my sigmas. These are my q's. So q's are written in rows, sigmas are written in elements of sigmas are written in columns. Fine. Now when I'm in Q0, when I see an input 0, okay, this arrow indicates in state Q0 with input 0, you will end in state Q0. Okay, so I start in Q0 and I end up in Q0 only. Okay, if I extend this now further, when I am in Q0 and my input is 1, this arrow takes me to state Q1. So this will be Q1. Okay. When I am in Q1, that is in this state, and input is 0, this loop will keep me in Q1. It won't allow me to leave Q1, right? So that is called as a loop transition. Transition is taking me back to the same state. Okay. Then Q1 on input 1 is taking me to Q2. So this is the thing that I fill over here. Q2 on input 0 keeps me in Q2. And Q2, sorry, I hit a wrong. I hit a wrong shortcut. Sorry for that. Q2 1 takes me back to Q0. Okay, now think about it. All the 5 ingredients are there. Q0 is a finite set, Q0, Q1, Q2. Sigma is a finite set, 0, 1. Delta is defined using this table, which is a transition table. The graph also is there. So it is defined. The mapping between current state, current input to next state is there. Q0 is there, initial state is there. Then I have final state. That means I have everything for this to be referred to as a finite automata. Now we will see if I give input 0, 1, 0, 1, what will be the state in which the device will end up. If my input is 0, initially always the device starts in 0. So on input 0, it will stay in input 0, so Q0. Then on input 1, it will go to Q1, which is, so now, so far the device has seen prefix